SFT and BMD. First, next previous lecture I discussed sign convention of shear stress. Suppose this is a body. When is clockwise rotation, sign convention sign convention convention for shear stress the left right, this is positive and this is negative sign convention, counterclockwise or anti-clockwise. So left to right, 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 upward shear force, upward shear stress, not shear force, upward shear force positive, left to right, and left to right, and downward, this is downward, this is negative, this is positive, left side upward positive, left side downward negative, right to left, right upward, right downward positive, downward positive, and upward negative. Understand? Negative. Next, for sign convention for bending moment, BM, bending moment, when sagging or concave, this is sagging, left right sagging, this is positive sign of bending moment, and hogging, this is hogging, negative, left right. So we can left to right, this is left to right, clockwise movement, this is clockwise positive, and left to right counterclockwise, anti-clockwise movements negative, and right to left, right to left, right to left counterclockwise anti-clockwise moment positive and counterclockwise moment negative. Understand? And in this case of sagging, this is sagging the curvature, center of curvature, positive y direction, and this is hogging, center of curvature, negative y direction. And shear force is denoted by capital V, and bending moments is denoted by M. First, this is a simply supported beam. Suppose this is simply supported beam. One end hinge and other end is roller or knife edge, and both ends are both supports are situated at extreme end, and entire uniform acts entire span of beam. This is straight line. Run per unit. This is intensity of load. Run per unit. Now the relation between intensity of load and shear force. Suppose this is L, or span of the beam L, and suppose we take a small element dx. Consider, draw this dx portion. This is beam, this is dx. This side shear force V, and this action, this is reaction, and downward V plus dV, and moments M, bending moments, and this side's moments M plus count opposite. This clockwise, this is anti-clockwise, M into dm, and thus centroid of the elements, this is centroid C, centroid from left side dx by 2. This is W per run unit, per unit length, per run per unit. Now suppose summation of shear force. What is definition of shear force? Shear force at section, summation of all transverse loads in up to the section. This is section. Summation of F V equal to 0. Now from here we know the shear force left side upward positive. Now there is a loads. This is W into length equal to load, load, and this portion load is W into dx, total load, and the center total load, and left side downward, negative, W into small w into dx, total total intensity of load W and length dx. This multiply, and this is centroid and does not depend on the length. Shear force, just summation of transverse force in the vertical, in summation of vertical loads. And this side, and left to right, and this is downward, minus V downward. This is left to right. We are going to left to right. Left side upward positive shear force, and right left to right, and downward negative, and vice versa. And V into dV, V minus V plus dV equal to 0. There is no, and two moments, no, three loads, one V plus dV, and downward, left side down negative, and this is downward negative. So V minus, calculate the value, small w into dx minus V into dV equal to 0. VV cancel, and so from the equation we get dv by dx equal to, this is the relation, very important points for any kind of exam. This is called change of rate of change of rate of change of shear force is known as intensity of load, or we can say slope of shear force diagram at any section is equal to intensity of load at that section. This is slope of shear force diagram is equal to intensity. This 2 point is very, very important for any kind of exam. Now suppose, and now the another relation between shear force and bending moments. Suppose summation of MC equal to 0. This is equilibrium condition. Summation of F equal to 0 and summation of M equal to 0. Summation of, and we know, first of all write this first, sagging positive, left to right, hogging left to right, left side to left to right, clockwise movement, left side clockwise moment clockwise moment positive. This is clock. And left side anti-clockwise moments negative. We know, just condition sagging and hogging. Suppose the moment clockwise direction, summation of MC, taking moments about point C. M clockwise direction positive, and shear force into distance is a moments. After this is clockwise direction, a V into this d into dx by 2, and W, and the action of W, the centroid of the elements, so plus W into dx into 0, and left side counterclockwise, this is load into distance, counterclockwise sense, মানে anti-clockwise moments negative. V plus dV into dx by 2, and anti-clockwise moments, left to right. We are going to left to right, not right to left, understand? And this counterclockwise or anti-clockwise, m into dm equal to 0. Now calculate m plus v into dx by 2 into 0, this 0, minus v into dx by 2 minus dv into dx by 2 minus m minus dm equal to 0. Cancel out this one and this one, and both are small, very so negligible. This one 0, and sorry, there is one mistake, and right to left counterclockwise, anti-clockwise positive moment positive, and clockwise moments is negative, means this is negative, clockwise negative. Hogging, sagging. Here first taking moment about C, point C, left side, this is left side about C points, clockwise rotation, clockwise moments positive m, and force into distance, this one is clockwise rotation, and distance dx by 2, this sign is positive, and W into dx, total load, and the center passing to the centroid, so the value is 0, and V plus dV is right side of the point C, and right side, this sense is clockwise, right side clockwise right, this is clockwise, and sorry. uh, Understood this point, and this we are going left to right, and left to right, clockwise movements, and this one is clockwise, also clockwise, left to right, this left and right. We are calculating left to right, the sign will be positive, this will be positive, because this clockwise, and this one is anti-clockwise. Sorry, big mistake, this one positive sign, so, and this one positive, so write it. So dx by 2, this one dx by 2, and this one is negligible because both are very small, and is cancel out. V into dx by 2, v into dx by 2, v into dx, and dm minus dm, and minus dm equal to 0. Understand? Yeah. First we taking about point C, and this is movements clockwise, left, we are going left to right, clockwise movement positive, left sides, left to right m, and this also clockwise, and this is past center, that's why this value is 0, distance is 0, and this one also clockwise, we are going to clockwise movements positive, and this one anti-clockwise, left to right, anti-clockwise negative, so this sign is negative, and then calculate and get v into dx minus dm equal to 0. We get v dm by dm equal to dx equal to v. This one is very important. Rate of change of